This is Dr. Carroll, and today's video is about do-while loops. Now, with the do-while loop, the continuation criterion is checked after the executing the loop. So let's look at the syntax for this. So obviously we're going to have a do, and then we'll have curly braces to define what the body of the loop is. And then not surprisingly, we're going to have a loop and an expression. I call that expression the continuation criterion because it defines when are we going to continue. And now something not to forget, which is going to feel a little bit awkward, is that semicolon after the while statement there. And that defines the end of the do while statement there. Now, inside the body, we can have we can have 0 or more statements. It's very rare to have I can't think of when you'd want 0, so you're going to have 1 or more statements inside the body of that loop. Okay, and that's the simple syntax. It may be new if you're coming from another high-level language than C++. Okay, so now notice that the body of the do-while loop will be executed at least once. It's guaranteed. That's not always guaranteed with other loops, and that really sets the do-while loop apart. In contrast, the body of a while loop, for example, may never be executed. That's rare, but it's possible. Let's look at a flowchart of what this would look like. So this rectangle with circular corners, rounded corners, is what you could consider the entire do-while loop. And so as we enter the do-while loop, we're going to execute 1 or more statements here. We'll then test the continuation criterion to see if it's true. And if it's true, then we're going to execute the statements again, and we'll just keep doing that until the continuation criterion is false. And when it's false, we then start executing the statements after that. And yes, it is possible to have an infinite loop with a do-while loop. Now let's see an example. So here we have some fairly basic code. We're going to ask the user for a response, and we're going to guarantee that they have typed a lowercase y or a lowercase n, and we will accept nothing else. Now, you might want to extend this to also take an uppercase y and an uppercase n, but just I've kept it simple here. So the execution is going to come. We have our do and our curly brace, and then we have a prompt here, and then we're going to get a response, and so that will be executed every time, which is what you would expect for getting an answer. You have to ask at least once, maybe a lot of times. And then we will continue asking if we didn't get a y and it's not equal to an n. But if it equals one of these, then that will be false, and then we will stop executing the loop. So we're guaranteed to at least execute the cout statement, the cn statement, and then test the continuation criterion. And the question is, are we going to iterate on that loop or not? And when we're done, then we have this cout statement here. Let's see it. Okay, so if we type in maybe, an M for maybe, it's really not happy about that. We could do exclamation mark. We could do a 0. And it's not until we hit Y or N that it works. Now let's see that again. Now what if we just hit N to begin with? It still works. That's it for today's video. I hope you enjoyed.